So let me introduce Mrs. Katranski to you. She studied mathematics, but then she took and took a different approach and joined Vector, and she's now a product manager for VTest Studio. And therefore, when it comes to test design, test modeling, she is the expert, and she's going to report from exactly this field. Well, ladies and gentlemen, I hope I can cheer you up after lunch. And I'm going to talk about variance and traceability as a challenge and model-based activities as the solution. This morning, you already heard that we have a model-based approach on the simulation side, and now we're going to talk about model-based approaches in test design. So what are we talking about specifically? We're talking about automated ECU tests, module tests, subsystem tests, model in the loop, software in the loop, and hardware in the loop. What are the challenges for the test designer? Well, of course, without traceability, nothing is possible. I have to deal with ECU variants, test variants. And of course, I don't want to do copy and paste all the time. I want to make sure that I can reuse my elements of the test design, then also reviews. I have to be able to show what I've tested. And I also want detailed reporting, and all of that has got to be reproducible. I have short change request cycles, so I need good maintainability and extendability, and test coverage should be good, and I might also have distributed development and design with distributed roles, different roles. So the test designer, might suffer a headache from all these requirements. So what can we do about all that? Well, what is the first thing for the test designer? It's the requirements. So I have a list of requirements, for example, a light ECU, and could be formulated in doors. And these requirements have to be covered by my test design. And I also always have to make sure that there is traceability, and this is not enough. When it comes to requirements, I have different variants for my automatic light control. I have a threshold value where the light has got to be switched on or off automatically. So the ECU might be different for the USA, for Europe, or one with bending light, one without a bending light. So, certain different requirements need to be covered. So I have a lot of variants. So what would be an approach to setting up the testing? Of course, light control. Usually you have just two states that need to be described, or my light is described. It's two states, on or off. So I could say, okay, let's use state diagrams in order to design my test cases. So what do? I describe the expected behavior of the system under test as in the form of a state diagram. What's important now is that the test model is separate from my functional model, because if I want to find faults in my functional model, the test model has to be separate from it. So we have two states, on and off, of course. And then I have switch on and switch off. These are the transitions from state A to state B, manual light control or automatic light control. If the ambient light for a certain time exceeds a threshold, then the light is supposed to be switched off automatically, or the other way around. So these are the states described in the context of my requirements. So what is the special thing about my test model? Well, I can extend the test model by means of test-specific transitions. So I'd say, well, non-unspecific scenarios such as switch light off when the light is already off, or I might say my ambient light exceeds a threshold value, but only for a very short time. then I don't want the light to switch on and off automatically. Or I have boundary value checks. So what happens if the ambient light is exactly on the threshold value? Should it go on or off? And then also time-based requirements. So in order to be able to test these states, I need some initialization as well. So as to put my ECU into a valid initial state, or I want to say shut down my ECU based on a specific state. So I have my expected behavior, or the behavior is described in the form of a state diagram. So how do I get to my test cases? So we've already modeled our transitions, so we want to test our transitions. So I want to achieve a certain coverage of my states. When I generate test cases, what I do is I say, well, my transition, my stimuli and states, the states are mapped to checks and the transitions are mapped to stimuli. And then I can take different algorithms in order to generate my test cases based on the model. So different algorithms, few test cases versus short test cases. One possible approach would be the Chinese Postman algorithm. So if you were to apply it to this situation, then one long test case would be the result. So with as few test steps as possible, I would like to achieve a full coverage of my transition. Or you could also say, well, such a long test case, I don't want that. I want several short test cases, so I could use the breadth search algorithm. Fewer test cases, more test cases, would be the result with fewer test steps. Or I can go to the extreme and say, I want to be even more granular. So for every transition, I want one test case so as to be as granular as possible. So what you can see here, these are some cryptic test case names. These are the transitions or the designations for the transitions that the system goes through in the test case. So let's take one example from here. Initialize, switch on, switch off. What does this mean? Well, I just walk through my diagram, initialize, then I can see I'm in the state off, then I simulate switch on, I check that I'm in on, go back to off, and I check whether I'm off, and then in the end I have the cleanup. So here we would have short test cases, stimulation check, and then here is a long test case with a number, or with quite a high number of test steps. So this would be three approaches as to how I can create test cases from my model. So far we've been on the semantic level, switch off, check off. Now the realization and how I stimulate my system, this is something that we haven't covered yet. So let's do that now. We separate the graphic from the actual test implementation. So far, we haven't even discussed what the hill axis looks like, but you've already understood what we're talking about. So by separating the graphic and the test implementation, I'm on an abstract level. So we're completely away from, we have no problems with ECU variance access to my hill environment. So one of the great advantages is that I can do reviews very easily without the need of having this detailed knowledge. Now, test implementation and parameters. So this transition here, for example, the ambient light is to be stimulated or simulated. So I can add a function which provides ambient light on the threshold value plus 500. but the threshold value was variant dependent, could be different in Europe than in Asia. So I could then do a parameter, an extra parameter file. So for which variant I use the test, I either use 5,000 lux or 7,500 lux. Or checking whether my light is actually on. So this is maybe the implementation is different, not only parameter values are different. I have conventional halogen light, I have to check whether the voltage exceeds a certain value, or otherwise I have to check a PDM signal. So at this level of the implementation and the parameters, I do the differentiation of my variants. But my graphic is completely independent of that. I can reuse that. And another advantage is that I can separate roles. The test designer, who is responsible for the graphic, is not necessarily the same person who does the hill or the person who is responsible for the ECU parameter threshold values. So that was one model-based approach as to how we can create test cases. On the other hand, what can happen is I can say, well, that's all fine and well, but the coincidental generation of test cases from my state diagram might not help me if I have to model a test sequence where I have a certain sequence of commands in order to put my system into a certain state. For this purpose, we have the notation of so-called test sequence diagrams. So what I do here is, as opposed to the state diagram, I actually model my test sequence, the testing sequence. So I say at the beginning, I want to initialize my system, so I switch on the ignition, and then I want to say, well, let's give me different test cases, engine speed 1,000, 1,300, 3,000. And for each RPMs, please check the right-hand indicator or the left-hand indicator. So that's the chronological sequence of my test command. So I can tell the test which steps to execute. And if I need a certain sequence in order to put my system into a corresponding state to achieve that state. And then variant dependencies, I can model them as well. Variant-dependent test sequences, variant dependency. Well, if I say, okay, if I have a bending light available, then I have to check that if the indicator is set, the bending light has to kick in. Otherwise, I don't have to do that. And then, in the end, I switch off the indicator and just verify that this has worked as well. And since this is the way to define the test sequence with the individual steps, I can say at that point, well, for a certain range from here to here, I want some background monitoring to make sure that my indicator frequencies reach a certain value, target value. So that would be a different kind of notation for the graphic design of test cases. And I've already kind of suggested it. How does a test case generation, or what does test case generation look like? Well, it's not a generation, really. It's you don't generate it because the test cases are actually specified the way they should be. So each pass through this diagram represents one test case. So again, transitions, corresponding stimuli, checks. Transitions are mapped to stimuli, states are mapped to checks. So variant cornering light available. I have the following 6 test cases. What is behind that? Well, one example, that's for the first example, it would say, well, I start here at the top, or I switch off ignition, then I go to left, set RPM to 1,000, operate indicator left, and I'm here with a variant that has a bending light, so I go to the left and I verify that the bending light is activated, and then I switch off my indicator again. So let's take a look at the second test case, and there we would see that this set of slides has not been checked appropriately. I actually initiate the wrong path, because what I wanted to show you originally was that we reuse the same parts that are the same in the test, and that is also the case. But this is actually the third test case. But I'm sure that you can imagine what I mean. So I just take every path through that is possible through these diagrams in order to test the individual variants. And if we take the other variant, cornering light not available, then this is what it will look like. Let's take the first test case. It will only be here in where I take a right, and this test or check is just dropped. So I can reuse everything. I can just map it with the graphic. So we have two approaches, state diagrams on the one hand and test sequence diagrams. What is the difference? When do I take what? Well, state diagrams are state-oriented, test sequence diagrams are sequence-oriented. So here I do descriptions. With the test sequence diagram, it's more that I do specification. On the left-hand side, it's more concise, more compact, and the test sequences are expressing. So what shall be tested? That's the question that I asked for the state diagram, or how shall be tested? That's the test sequence diagram. So different ways of creating test cases, or one straightforward approach to generate test cases. But both approaches are useful, and you can also use them in parallel. It actually depends on the characteristics of my system under test, or the test task, or the requirements of the test design, which one I go for. But in the final analysis, the graphic notations are different. The orthogonal concepts such as abstraction, separation of test implementations, they are the same for both cases. And the test cases that are generated are of the same type. So somebody who then uses the test doesn't have to think about which notation was used when the test was designed. They will just carry out the tests, and the reporting will also look the same. So the person who carries out the test doesn't have to take care of that. So this means that the test designer is already happy, because he's already written test sequences for all test cases. But what do we need? Well, what else do we need? Well, we need traceability. The test designer needs to have an overview of what he has tested already, or whether something is missing. And I have internal and external reviews where I have to show, yes, my test coverage is sufficient. And then also, if I want to connect it to test management tools, then in my test design, I need to be able to prove that this test design covers these test cases. So what do we do, or how do we do it? Well, again, let's move at the level of graphics. So it's important when you have reviews. I don't want to go to my C# implementation. So we say, okay, each test case that contains a graphic element which is linked with the one requirement, this test case automatically covers these requirements. So my state diagram, as an example, I would say, well, here I cover the requirement of manual light control, whereas here I cover the requirements for automated light control. So in the graphic, I link the requirements, or I map the requirements to the test cases or test sequences. And the same applies for test diagrams. And actually what I get in the final analysis is a traceability matrix. You've seen that before. So I get an overview of all my test cases and the requirements that are covered or not covered by these test cases. And I would like to draw your attention to the variants. I can also say, well, show me the test coverage for the variants, for the specific variants, and also for a superset of variants. So specific variants such as testing for Europe, for example. So I can move from here to the implementation of the test cases, and that simplifies the change management of requirements. So I always have an overview of the test cases that need adaptation, and then I can just navigate there if required. So we're at the Vector Congress here, so let's do some advertising. Of course, we also support model-based test design in our test design tool, VT Studio. There's just a small asterisk here, test sequence diagrams. We already have that. State diagrams will be implemented from January next year onwards. Then we have the Canoe tool, that's the test execution environment, and the close integration of VTest Studio and Canoe allows direct access to the complete system, all the features of Canoe, such as, for example, we saw the Canoe application to car maker, so you can also combine it with car maker. So the only question that is left is how we connect this to test management tools. We do this via Exchange formats. So we would define our requirements for the test management tool. We implement it in VT Studio, link it to our model-based test design. Then we get to the generated test cases. They are linked to the requirements. This information is loaded back to the test management tool, and then we get the information for implemented test cases that we then have available there. And after the test cases have been executed in Canoe, the test results can be loaded back so that I have the full traceability of the requirements, test cases, and the execution. So this already brings me to the end of this presentation. What have we seen? Well, we have seen model-based test design as one solution for handling of variance and traceability. And if we then use the vector tools for this purpose, then this is rather useful. So, and this is how we have made our test designer happy. Thank you. Thank you very much, Ute. So I will go back and write test cases immediately, or well, not write, actually design or model. Are there any serious questions to Ute? Any further questions? So we've done some advertising already. Now state transition diagrams will be supported soon. What are the algorithms that will be contained there for the selection of test cases? Well, we will begin with the postman, the Chinese postman algorithm. Then the breadth search will also be included, and then we will take it further, and we'll see. Now, that was a very limited state diagram, and we've already produced some test cases out of that. And this is bound to explode, because then the next question will be, how can I reduce the number of test cases that I've generated by, for example, doing annotations or only test these paths or generate all paths that test this requirement or maximum number of test cases. So these are things that will become interesting. Thank you very much for this interesting presentation, Julian Hamper from ZF Friedrichshafen. So with VT Test Studio and the test design, can the status review be set, and can we draw baselines such as for ASIL? The test specification has to be reviewed. So I would like to have the same tool to be able to maintain the review state so that I can see that it had already been reviewed. Yeah, that's an issue that's on our agenda as well. Well, we're probably going to take a more general approach and say that there are test case attributes that you can define yourself and that you can maintain as metadata. But the trigger for this feature was specifically or precisely this use case, that the life cycle of a test case has to be maintained, where you say, okay, I have an attribute lifecycle reviewed in implementation and so on. You can set this as a test case, and it will also be contained in the report. You can filter for it, copy, and so on. Now, planning is already possible. It's been planned, or we were planning it. Whether we will have it for the next main release, we don't know. We've planned to have it, but it will come in the course of next year. Thomas, any questions over WhatsApp? No, maybe that's not necessary because we're all in this room anyway. Anyhow, thank you. Thanks very much.